Students, I'm going to do a little review for chapter 4 here, and I'm just going to go over a few very important things from the chapter just to prepare you for the exam. So in 4.1 we talked about graphing quadratics. So here, over here on the side, you'll see a graph. This blue graph is called a parabola, and here's the function f of x equals 2x squared plus 2x minus 12. Okay, so it's important to note that when we graph, the x-intercepts right here and right here, that's where the graph crosses the x-axis, those x-intercepts are called roots of an equation, okay, or zeros of the function, or the x-intercepts, okay. So x-intercepts, roots, and zeros are all going to be really the same thing. When you're talking about a graph, the x-intercepts and the zeros are what we're commonly going to call them, okay. Now, when we get into an equation, okay, so this is what really we're after in this chapter, is solving quadratic equations. So from the graph, if you're given this equation right here, and you want to find the solutions to this equation, as long as this equals 0, what you can do is substitute a y there. So y equals. Then you graph that function and find the intercepts. You see how this was 0 before? So really, if you look over here, this y was 0. So if you find the zeros, that is all the x values right here for that and that, the x value that would cause this equation to be 0. So again, those are the x-intercepts of the graph. They're also the zeros of the graph and the roots or the solutions for the equation. Okay? So solving quadratic equations is what this chapter is all about. And the first way you can do that is by graphing, okay? So sketch the graph. Once this is 0 over here, get everything over to the left side. If this is 0, then just change that to a y and graph it. Now on your graphing calculator, I'll go over this really quickly. So on your graphing calculator, you hit the y equals, and you're going to want to make sure this is clear, and you want to make sure that nothing is highlighted up here, okay? So if it's highlighted like this, if it looks like that, that's bad. Go up there, hit enter, deselect it. So what I'm going to do here now is I'm going to graph this graph right here and show you that the solutions are the x-intercepts and how to find those. So 2x squared plus 2x minus, now this is the minus sign, remember, this is the negative for the very beginning. If it's a negative, they have to use this button. But as a minus, you use this minus button over here, minus 12, okay? So now I'm going to graph that. You just hit graph. And your calculator may look like this. Look at that. That's all whacked out, right? So if that's a problem, hit zoom 6. And that will get you to a standard window, and that's generally a window that's going to show a lot of these roots. Okay? You may have to adjust your window settings as well. Look up that video for 4.1, the full video, if you want some instruction on that. So we see that here are the intercepts, and those are going to be the values for x that cause this whole equation to equal 0. All right? And so quickly, how do we do that? Second function, the trace button, gives us to the calculate menu. Number 2 is 0, so hit number 2. Now it'll say left bound, okay? So what you're going to do is you're going to get your cursor over, or you can just type a number straight in if you know it's over here, right? You can do that too, so I'll do that in the next one. But left boundary, so this blinking cursor is to the left, right here, of the intercept. You say yes. Then the calculator will ask you for the right boundary. You can either move your cursor over, or you can type in like a -2 or -1. Watch this. -2. Enter. You see how it puts up that little boundary there, and it automatically goes there. So you can use the cursor or just type in a value that you know is to the right. And then it'll say guess. You hit yes, and then the cursor should show up right there. And this value, x equals, that will be your one solution, so -3. Notice in the diagram, that's an intercept, -3. So that's one value there, one solution. And the other, you do the same thing for the other one, which I won't do in this review. Okay? So that's graphing. All right, so 4.2 was about factoring. We spent a lot of time factoring. This is something you're going to need to remember how to do and use the zero product principle. So factoring is important. So if you want to factor something like 3D here, what you want to do first of all is notice that there's a greatest common factor of 2 in all of these terms. So take that out. Okay. And then you want to focus on this trinomial. Now because this is a 1 right here, this is easy. You look for two numbers that multiply to 9 and add to 6. So this is what I always do. I always put this number up there and I put down the, list all the factors. Okay? -3 and -3. So which set of these factors add up to positive 6? It's these two. So guess what? This is really easy. Keep the 2 there. And now you're going to write the 2 binomials that multiply together to get this trinomial. And of course, x times x right here is going to give you x squared. And then you use these numbers, plus 3 and plus 3, excuse me. Excuse me. And that is now fully factored. Each one of these factors cannot be factored anymore. You're done. Okay? These are differences of squares. So remember 4y squared minus 9x, if you want to factor that. It's a difference. There's a subtraction. These are perfect squares. So 2 binomials. The first term in each is the square root of the first term. 2y and 2y. And the second term is the square root. So it's a square root of the second term. Separate that by a plus and a minus and you're done. Okay, that's difference of squares. For this one down here, okay, if you've got something like this right here, this looks like a quadratic, but it's a little more complicated. So don't fret, don't worry. But what you might want to do is let this expression right here equal a variable. So let's let x plus 2 equal w. And then this equation, if this is a w and this is a w, it becomes something that's a little bit easier to factor, okay? So now you can factor this, that's no problem, right? 2 numbers that multiply to negative 42 and add up to negative 1, well, that's going to be negative 7 and positive 6, isn't it? So this is going to be w minus 7, w plus 6. Now I substitute back in and I get x plus 2 minus 7. That's this w is now substituted here. And x plus 2, again, plus 6. And you go ahead and simplify that. I'll just continue that. Oops, so you can see that. Continue that down here. So gather like terms. 2 minus 7, that's going to be x minus 5. And 2 and 6 is going to be x plus 8. And that's your factored expression there for this one right here. Okay, for 5a. So that's 4.2. Well, actually, sorry, that's just factoring. Solving is using the zero product principle. You factor first, then you let each factor, that's a factor, that's a factor, let them equal 0, and then solve for your variable. Boom, you're done. So factor and let each factor equal 0. So there's a factor, let it equal 0, x equals 0. There's a factor, let it equal 0, solve for x equals negative 5. So that's the zero product principle. You've got to know that. 4.3 is, what's 4.3 here now? 4.3 is, completing the square, right, completing the square. So for this one, I don't know how you felt about this one. You can look up that lesson, but let me just give you an example here, I guess. So if we had something like 4x squared plus let's say 20x equals 15, okay? And we're going to solve this by completing the square. Well, what we're going to do is you can leave this constant over here. You're going to focus on these two terms, the x squared and the x term. You're going to factor out the 4 here from those two, okay? And then you're going to complete the square, make this a perfect square trinomial. And whatever you add to the one side, you're going to have to add to the opposite side as well. And so how we complete the square? Take half of this b term and square it. So this becomes x squared plus 5x. Half of 5 is 2.5, or 5 over 2. You squared that, that's 25 over 4. Ready to see that? Half of 5 is 5 over 2 squared. It's 25 over 4. So that's 15, and I have to add, what did I actually add to this side by putting that there? Well, I actually added 4 times that. So that's actually, I added 25, so I'm going to add 25 to both sides. Now this becomes x plus 5 over 2, all squared, equals 40. So that's completing the square. Solving by completing the square is now going ahead and solving for x. You see here, x was in two different spots. We can't isolate for x when x is in two different places, unlike terms. But now we have x in one spot. So this is going to be easy. Divide both sides by 4. This is going to be x plus 5 over 2 squared equals 10. Take the square root of 10 and the square root of this side. When you take the square root of a number, it's always plus or minus. 5 over 2, it's going to be plus or minus root 10. We're going to leave that as an exact answer now. I won't change that to a decimal if I want an exact answer. And then x is going to be plus or minus root 10 minus 5 over 2. And you can write that in any order you want, meaning it could be this, root 2 plus or minus root 10. So those would be your two solutions, negative 5 over 2 plus root 10 and negative 5 over 2 minus root 10. That's exact. And you can plug those into your calculator to get decimals if they don't want exact values. But if you want exact values, you've got to include this square root. You have to leave that in your answer, okay? All right, so that's completing the square. Let me talk to you a little bit about, let's see, 4.4 was quadratic formula. And come on now, quadratic formula. Okay. Quadratic formula was right here, and you know the song, x equals negative b plus or minus root b squared minus 4ac all over 2a. All right, quadratic formula is easy to remember. And there's a part in here that's really important, this b squared minus 4ac. So one of the things I want to make sure that you remember is that if you want to know the number of roots or the nature of roots, you focus in on your b squared minus 4ac. So let's say we have y equals x squared plus 11x plus 30. Now we could solve this by factoring, by graphing and finding the intercepts, or by using quadratic formula. The nature of the roots is what b squared minus 4ac is like. So what is b squared minus 4ac here? Well, this is 11 squared is 121 minus 4 times 1 times 30, so that's minus 120. So b squared minus 4ac is going to be positive. We have 121 minus 120. So this is 1. It's a positive value. So we have 2 real roots. Okay? Quadratic formula. Let's actually go ahead and do this. So it looks like this. So negative b is negative 11. Plus or minus. Well, we figured out what this was. But let's write it out here. So that's 11 squared minus 4 times 1 times 30. All over 2 times 1. So as we continue through this, we get negative 11 plus or minus. That's 121 minus 120. That's square root of 1 over 2. So there's 2 roots here. 2 real roots. They are irrational. So you can't simplify them. And the exact roots would be x equals negative 11 plus, root 1, right? Sorry. Root 1 is just 1, so they're not irrational, my bad. They're rational. Weird. Okay. So what do we have here? Wow, I got thrown off there. You have this, and you have negative 11 minus root 1. Yeah, I just realized I'm writing root 1. That's silly. Okay, so this is negative 11 plus 1 over 2. And negative 11 minus 1 over 2. Irrational. So we have, what is this? Negative 10 over 2 is negative 5, and negative 12 over 2 is negative 6. So those are your roots. Quadratic formula gives you that. 2 real roots. Yeah, I see I wrote 1 there. If you have something like the example from some crazy example where we have, roots that have radicals in them like this, you see? Okay, so b squared minus 4ac is still going to be positive, but it's not a perfect square like root 1 is. And so that means you're going to have the simplified roots are going to have a radical in them. And it would be good for you to maybe look at how do we simplify radicals. That might be a video you want to watch again. It's too much to go over right now. But remember, exact roots have radicals in them if necessary. And if it was like this example I just did, you don't have to write root 1 as your final answer. You can just write 1 and then simplify. So these are exact right here. These are exact roots right here. Okay? I think that's pretty much it as far as the review for Chapter 4. You need to know how to solve by graphing, solve by factoring zero product principle, You need to know how to solve using the quadratic formula. And you need to know how to complete the square and solve that way, like we did in 4.3. Okay? So, yeah, happy studying. I hope that gives you a good refresher of what we did in Chapter 4. All right, good luck on your exam. God bless.